Let's take one simple numerical of dichotomous method, and then we'll be moving towards our next method, that is the Fibonacci search method. Right. So the question that we have is find the minimum of z is equal to x square x minus 2 in the interval 0 comma 2 with 3 iterations using dichotomous search method. Dichotomous search method, right? So it has been given that we have to move only till 3 iterations. So as they have given the number of iterations, they haven't said anything about the accuracy as well. Again, the point to be noted here is that we don't know the value of delta. So the value of delta is to be assumed, right? So let's start with the first iteration. Here we can say assume delta is equal to 0.001, right? So here what we have is the initial interval is L0, which is 2 minus 0, which is equal to 2. So we can write x1 as L0 by 2 minus delta by 2. So substituting the values, we get x1 as 0.995, sorry, 995. Similarly, if we substitute the values in the formula for x2, that is L0 by 2 plus delta by 2, you will be getting the value of x2 as 1.005. We can also find out the value of fx. So now fx, if you try to find out here, the fx value turns out to be negative, right? So it is coming out to 0.9905 here, and the value of fx2 is coming out to be minus 1.0049. Yeah, right. So I request you to please do some calculations as well at your end, or try to solve the same numerical uh, again, right? So here we have this, that is 0 comma 2. We have this 2 points x1 and x2, and now this is a negative, right? So 0 minus 0.9905 for x1. So it's like this, minus 0.9905, and as it is a negative sign, you'll have to remember that minus 0.9905 is greater than minus 1.0049, right? So comparatively, no, the figure will be like this, right? So I haven't drawn on the upper side because it is a negative side. So graphically I have represented it below the line to just make a sense, right? So this is, no, I get I hoping that you have got this. So minus 1.0049 is less than minus 0.99 uh, 05, that you have to understand. So here what we can write, here f of x1 is greater than f of x2, right? And which region is to be eliminated? Now you have to remember it is a minimization problem. Hence, eliminate region. Hence, eliminate region. Which region you will eliminate? We don't want on the higher side, so we are going to eliminate region left of x1. Therefore, new interval that we are going to get, new interval is, what is the new interval? It is it is not minus, it is x1, right? It is 0.9995 comma 2. So this is our new interval, right? We can move towards our second iteration here. Second iteration, right? So here we'll have to find out L1. Here L1 will be equal to 2 minus 0.9995. So if you find out this value, L1 comes out to be 1.005. 0.0005, right? So we can substitute the value in the formula. X1 will be what? L1 by 2 plus minus delta by 2, sorry, x3, and x4 will be equal to L1 by 2 plus delta by 2. So substituting the formula, x3 will be coming out to be 1.4992, and your x4 value comes out to be minus 1 point, sorry, 1.5002. You can even find out the values of fx3 and fx4. So fx3 comes out to be minus 1.1256, and it comes out to be minus 1.1248. No? If we represent it graphically, so here it is 2, here it is our 0.995. This is x3, this is x4, x3 and x4. So in which x3 is on the higher side or lower side? X3 is on the lower side, right? And here, okay, x3 is on lower side and x4 is on the higher side, right? So I'll be just representing it on the other page, so there won't be any confusion, right? 0.9995, and here it is 2. So x3 and x4, x3 and x4. So this is minus 1.1256, and it is minus 1.1248, right? So minus 1.1248 and minus 1.1256, right? So that we have to understand, and no, here f of x3 is on the higher side, or x4 is on the higher side. F of x4 is on the higher side, x3, hence eliminate the region, let the region right of x4. That is very, very important. Therefore our new interval that we get, no, is 0.9995, comma, no, what is the value of x4? X4 is 1.5002, right? So now third and last iteration, our third iteration, right? Third iteration will be, now here we'll have to find out our L2. So L2 will be equal to 1.5002 minus 0.9995, and the value of L2, if you do the calculations, comes out to be 0.5007, right? Similarly, I won't be writing the formula again, x5 and x6. If you, put the formula, okay, I will be writing it L2 by 2 minus delta by 2. Here it is L2 by 2 plus delta by 2. So the value of x5 comes out to be 1.2493, and it comes out to be 1.2503. The value of fx5 and fx6 can be found out by putting the values of variable x in the objective function. So it comes out to be minus 1.1716 and minus 1.1719, right? So here they have told us to move till third iteration only. So here only you can see, the functional values of x5 and x6 are not exactly similar, but they are approximately similar. So this is our last iteration. Then therefore there is no need of graphical representation, as well as no elimination of any area. You can directly write down the x star is equal to 1.2493 plus 1.2503 divided by 2. Therefore, the value of x star here, that is the optimal point, comes out to be 1.2498. We can find out the value of fx star, right? And the value comes out to be minus 1.1718, right? So this is how this particular numerical is solved, and this is the answer part.